Hi everyone and welcome to Basic Chemistry 1. The topic of this video is average relative atomic mass. As the name suggests that it is an average of atomic masses, but before going into the detail or definition of average relative atomic mass, let us have a look at another term, that is isotope or isotopes. What are isotopes? Isotopes are the atoms of the same element having same atomic number, proton number, but different mass numbers. They are called isotopes of that element. For example, isotopes of hydrogen are H1, H2 and H3. Similarly, isotopes of carbon are C12, C13, C14. So I have depicted here these the models of these isotopes of the two elements, that is namely hydrogen and carbon. Let us zoom in this picture. Here you can see I have tried to draw three atomic models of three isotopes of hydrogen. For example, this is H11, or this is also known as H1. It has one proton in its nucleus. Here you can see H12 or H2. It also has one proton in its nucleus. Similarly, H13 or H3. It also has one proton in its nucleus with the positive sign. But you can see that the differ lies here in the number of protons. Here we have one proton in H1 or H11 there is no proton, and in H12 we have one neutron. Here we have no neutron. Here is only one neutron, and we can see in H13 or H3 we have two neutrons. So atomic number or proton number of the three atoms is 1 each, but the mass number is different. Here mass number is 1, here it is 2, here it is 3. So these are the three isotopes of element hydrogen. Similarly, you can see in other part of this picture that we have here. I have tried to depict the three isotopes of carbon. Here is C6 or C612 with 6 proton and 6 neutron in it. Here I have tried to depict the C13 or C613. It also has 6 protons in it and 7 neutrons. Here we have 6 proton and 8 neutrons. So the atomic number of this isotope is 6. This is also 6 and this is also 6. But look at the mass number. This isotope will have a mass number of 12, this will have a mass number of 13, and this will have a mass number of 14. Or we can say that the atomic mass of this will be 12, of this 13, and of that atom will be 14. So these are isotopes of the carbon. Similarly, along with isotopes of an element, different isotopes have different natural abundance, which is also known as percentage abundance. Percentage abundance means what is the percent of different isotopes out of 100 atoms, how many atoms are. For example, let us consider the case of hydrogen. So percentage abundance or percent abundance means that if we take a sample of hydrogen gas, how many atoms out of 100 are H11, how many atoms out of 100 atoms are H12, and similarly H13. These two terms, that is the isotopes and natural abundance of isotopes, we will discuss them, and these are used in determining the average relative atomic mass. For example, the relative atomic mass of chlorine is 35.5. It has two isotopes, chlorine Cl35, that is chlorine 35 with atomic mass or mass number 35. Similarly, chlorine 37 with atomic mass or mass number of 37, and the natural abundance 75% is chlorine 35, whereas 25% of chlorine naturally occurring is chlorine 37%. Now we are in a position to have a look at the definition of the relative atomic mass, or discuss the details of relative atomic mass. So let us have a look at the definition of average relative atomic mass. The relative atomic mass is the relative atomic mass is the weighted average of the atomic masses of all the elements, of all the naturally occurring isotopes of an element. This is known as average atomic mass or average relative atomic mass of that element. Two things are important. The weighted average. This is the weighted average of the atomic masses of all the naturally occurring isotopes of an element. Now, what is weighted average? What do we mean by weighted average? Weighted average means that it is an average that takes into account both the atomic masses of the isotopes and their natural abundance of these isotopes. So this is the definition. Here you can see the weighted average of the atomic masses of all the naturally occurring isotopes of an element is called the average atomic mass of that element. Why do we take uh, average average relative atomic mass? You might have seen in the periodic table that atomic masses of almost all the elements are given in decimal fractions, not in exact whole numbers or exact whole number integers. So this is because, as we have discussed, that most elements occur in nature in two or more than two isotopes. That is why we have to take the average relative atomic mass, which is weighted average. And isotopes, why they are called isotopes? Iso means same and topos means place. So for all the isotopes of an element, we have single place, one place in the periodic table for these isotopes. That is why they are known as isotopes of that element. Now we have discussed the isotopes types, isotopes of hydrogen, isotopes of carbon. Now let us have a look at the how we can determine the average relative atomic mass. What is the mathematical formula? How mathematically we can find out the average relative atomic mass for different elements. So formula for this is, you can see here at your screen, the very simple formula. We take the atomic mass of isotope 1, atomic mass of first isotope, multiplied by its percentage abundance, plus divided by 100, plus atomic mass of second isotopes divided by 100, plus and so on. So on means it depends upon the number of isotopes. For two isotopes, if an element has only two isotopes, these two terms will work. For three isotopes, you will have to add another term with atomic mass of the third isotopes and percent abundance of that isotope divided by 100, and so on. Now let us apply this formula. Here you can see at your screen that I have written down that for example, the average atomic mass of chlorine is 35.5. How is it so? There are two isotopes of chlorine, chlorine 35, chlorine 37, as you can see at your screen. The natural abundance, or the percentage abundance of Cl35 is 75%, and that of Cl37 is 25%. And as the name of these isotopes suggests, the the atomic mass of Cl35 is 35, Cl37 is 37% abundance. We already discussed. So let us put all these things in the formula which we discussed in previous slide. Every atomic mass of chlorine, atomic mass of Cl35 multiplied by its percentage abundance divided by 100, plus the atomic mass of Cl37 multiplied by its percentage abundance. So average atomic mass of chlorine 35 AMU multiplied by 75%, 37 AMU multiplied by 25%. Both are divided by 100, and these the two terms obtained are added, and the answer is 35.5. So in this way we can find out the average relative atomic mass of all the elements by using this formula. I hope that this video will prove pretty helpful for you people. I'm thankful to you, and thanking you for watching this video. Please don't forget to subscribe to my channel and click the bell icon for more updates. The upcoming video will be on ions and different types of ions. Thank you.